So next I'll dive into the quantitative aspect of the college level content by using our red tide spectrometer. This spectrometer is one of our highest selling spectrometers. It's so high quality, it's very durable. I've been in classrooms where a student actually got really upset and he kind of slammed it on his desk, and the teacher said, you know, hello, that was $1,000, but it still worked. So even when physics makes you so mad that you want to throw your spectrometer across the city, don't take my word that that will survive, but I'm just trying to say that it's a nice quality spectrometer. So we're going to be using our red tide spectrometer to turn this from a qualitative analysis to a quantitative analysis. So you want to measure the wavelength of each vial using the spectrometer. So you probably won't be able to see this very well. I don't have my computer running just because I don't think you'd be able to see the visual very well. But what you'll want to do, it's very easy. You'll want to illuminate each LED, or each vial with the LED, and simultaneously take the spectrometer probe and measure the light. So it works best if the LED and the spectrometer probe are pointing in the same direction so that the light feeds into the spectrometer the most. So you'll want to place the spectrometer probe on the side of the vial while simultaneously illuminating it from below with the 405 nanometer LED. I've seen this set up in some classrooms where they have another clamp and they have a whole black light at the bottom so that they're all illuminated, which is great. The only thing that might happen if it's not pitch black in the room, if you have other light coming in, is the light might travel. So this red, instead of getting a pure reading of just red, since the orange is illuminated next to it, it might be a little bit skewed. So I always recommend people to do this experiment with very low lighting and illuminating one vial at a time so that you have nice pure results. So you'll want to initiate the software to record the radiated wavelengths. We use LoggerPro, which is my favorite. So using the peak wavelength, you'll want to calculate the size of the quantum dots. So again, just a few tips and tricks on how to use this in the classroom in the most optimal way. I like to use the ring stand and clamps. You don't have to. If you have a group of kids, one kid can hold themselves, one kid can put the LEDs under the vials, one kid can hold the spectrometer probe. But if you have one per person, you'll want to just set it up on a ring stand with a couple of clamps so that you can use your hands nicely here. So it's a matter of preference, but I like to set it up this way so that it's optimal use. Now I have included some sample results from my LoggerPro software that we're just gonna slowly cycle through on the PowerPoint. The first one is our blue, because what the students will learn is that the smallest quantum dot is the blue. Then we'll go to green, then orange, and then red. So these are actually in order from smallest to largest quantum dots in terms of diameter. So on the PowerPoint, you'll see the curve of blue, then we'll go to the curve of green, then orange, and then red. So I just included some sample data for you. I've also included on the PowerPoint a list of the products that were used today. So I have the Senko Quantum Dots, which is an individual kit. It comes with this, as well as this hefty instruction manual that covers high school and college. There's several examples of each from each discipline with some background information also. And I've also included the classroom set of 5. That's a different part number that we uploaded so that if you wanted to have a nice big kit that will serve your whole classroom, we also offer that. And I've included, if you don't have a black light or a light emitting diode already, we do offer purple LEDs for purchase, and the one that I used today, this little blue guy, I've put that on the screen as well.